Hey, and welcome. Today I'm going to be talking about the telescoping series. And a telescoping series is best described in an example. Okay, so this question is going to be to find the value of the sum of the series. Okay, and one thing is they want us to actually find the sum of the series. And up to this point, most of the questions have been does it converge or diverge, not what's the value of the sum. Okay, and the series in question is this one. It's going to be the summation from n equals 1 to infinity of 2 over n squared plus 2n. Okay, and if we were asked, does this converge or diverge, that would be one thing. But we're not asked that. We're asked the sum. And in previous examples where we've been asked the sum, the main example is the geometric series. This is not geometric, so we can't do that. Okay. Um, and I also want to reiterate here that the geometric series is the main instance where you will see find the sum of the series. If it's not geometric, you might think to yourself, maybe it's telescoping. If it's not telescoping, well, then you've got a really hard life and you have to be very creative in trying to find the sum. Okay. So here's going to be a fact, and I'm going to tell you how I got this fact. 2 over n squared plus 2n, this is equal to 1 over n minus 1 over n plus 2. Okay, and this is from a partial fraction decomposition. Okay, so if I use this fact, this sum from n equals 1 to infinity of this 2 over n squared plus 2n, well, that's going to be the sum from n equals 1 to infinity of 1 over n minus 1 over n plus 2. And I'm just going to start writing out terms. When n is 1, I'm going to get 1 minus 1/3. When n is 2, I'm going to get 1/2 minus 1/4. When n is 3, I'm going to get 1/3 minus 1/5. Then I'm going to do n equals 4. Okay, and I'm going to get 1/4 minus 1/7. I can keep going. Let's do one more. I'll get 1/5 minus, excuse me, this one should be 7. I made a small little error here. Instead of being a 7 there, this should have been a 6. Okay, and this keeps going forever. Okay, now what I want to do is I want to take out my little pen, and I'm going to notice, hey, I have 1/3 appear twice in this list. Here's a 1/3 and here's a 1/3. They have the same value but opposite signs, so I get to cancel them. Okay, well, I have a 1/4 here and a 1/4 here. They have the same value but opposite signs. I get to cancel them. Okay, I have a 1/5 that appears here and a 1/5 that appears here. If we think very deeply about this problem, this 1/6 will cancel with a future 1/6 over here. This 1/7 will cancel with a future 1/7 over here. And all the terms cancel, and what I'm going to be left with at the end of the day when I apply the cancellation throughout the terms is I'm going to be left with 1 plus 1/2, the first two terms. So the sum of this series is 3/2, and we're done. Now, the point of this example is that a telescoping series, it's one in which all future terms cancel after some point. And this is an example of that, of being able to cancel the terms. The 1/3, the negative 1/3 cancels not with the next term, but with two terms that come forward. The same with the 1/4. It cancels with not the next term, but the one after that. So two more terms, the 1/5, etc. And that same pattern holds throughout the whole series here. Okay. Now, you could see different forms of this telescoping series. It could cancel with the next term. It could cancel with the terms that are 5 terms down in the line. But eventually, the key property is they all need to cancel. Okay. Thank you for joining me.